Okay, so we are in our assembly, and with the previous lesson, we were able to insert our two pieces of square tubing. And so we're going to build a structure here. And so what we want to be able to do is attach these two pieces together. Now, the problem is the pieces, we want to be able to work out where the holes are just based on where they are. So in the assembly, there is something called the Create Part Studio in Context. And remember, the search tools is a really useful way to find stuff when you're not sure where it is in the toolbar. So Create Part Studio in Context, it asks you for the origin. Most of the time, we just simply use the current origin. So we're going to do that, click the green check mark, and that is going to create a new Part Studio. Now, with this new Part Studio, Part Studio 4, you can see, and yours might be numbered differently. I have an extra Part Studio that I'm messing around with. You can see the stuff in there. So that's where it's really, really useful. So what we're going to do is we're going to create a drawing. So we're going to use this face for our drawing. So we're going to select Sketch. And that becomes this magenta color indicating that this is the geometry that we're using within this. That's the context of our drawing. So N normalizes our screen and we're good to go. Now, what I want to do is the U button allows me to use different things. So I'm going to click the U button, and you'll notice when I'm holding my mouse over this circle, when I get to a certain point, there's a little dot in the center. So I'm just going to use that, select, and by clicking those, I can then select the circle, and I'm going to do 3 points up here, 3 points here. There we go. So basically, I'm going to create a piece that's going to use those holes, um, and we'll have a piece of metal around it. So let's create the metal. Now I'm going to use the Use tool again. And what I'm doing is I'm just selecting that point there and that point there. And you'll notice that as I move my mouse around determines what's selected. So I'm just kind of zooming in. I've always found to make it work really smoothly. So those points are my reference points. I'm just going to turn that off. And I'm just going to do a little rectangle. So I'm going to use that point. I'm going to hold my mouse over it, click once. Whoops. Turn it off. I don't want a center point. I want a corner rectangle, G. So hold my mouse over it, click, that becomes a corner. That's more like it. Now you'll notice I'm holding my mouse over that point and then moving, and I get that dotted orange line. And that little icon indicating that the end of this point is horizontal to that. Perfect. Click that. That gives me some black lines because they're constrained based on that point and being horizontal to that point. And the blue I can move around, which I'm going to change that in a moment. I'm going to do another rectangle. And same thing, now I've got a point to refer to, so I'm going to click that point, going to go over and then down. So I haven't clicked yet, and there we go. So what I've got here is I've got two rectangles, and I want to eliminate that blue. The letter D on your keyboard opens the dimension tool. So I can select the line, select the point. So click on the line, click on the point, move your mouse, and we'll put that quarter of an inch, 0.25 inches away. And 0.25. Okay, so now I have a rectangle that's perfectly constrained. Um, I'm going to call this an L gusset, so sketch L gusset. And I'm going to go straight into my extrude. And there we go. It's extruding it. So I'm going to make this out of 1/8 aluminum. Solid new. Great. There we go. So there's my L gusset. Now, here's the problem. Let me show you the problem. I'm going to go back into this sketch, and I'm just going to create a circle. And that circle I haven't explained this, but it's tangent to those two lines, and the circle's diameter is a quarter of an inch. So when I'm cutting an L gusset, our CNC router has a router bit that's a round circular bit that it spins and it carves material. And you can see this is the problem, is that when I get to the corner here, it will go there and go there. So it's going to leave a chunk of material in the corner. And we don't want that. So what we do is we design for that. So we're going to use something called the fillet tool. And this is the fillet tool, F-I-L-L-E-T. I often call it the fillet tool. So I'm going to collect that tool. And what I'm going to do is I'm going to click that line, and it's going to ask me for my radius. Well, if I'm dealing with a 1/4 inch bit, that's a 1/4 inch in diameter. So that needs to be at least an 1/8 inch radius, 1/8 or 0.125. So that curves that around now. And you can see, because that line got broken, everything here is going like, what the heck? So what I'm going to do is I'm just going to trim that. So those little scissors can cut that off. And then this right here, so it's blue. So I just want to see why it's blue. Okay, so it's blue. So I'm just going to go, okay, let's do a vertical constraint to that point. And we'll just make those 2 points touch each other. Oh, then I've got this point, make it horizontal to that point. Okay, a little bit of extra work, but I do not want any blue in my sketches, because then you can accidentally move things, and this way you have to plan to move things. So if I open this up now, you can see I've got a nice little curve in the corner. That's great. Now, the other thing that we talked about in class is we talked about, if you look at a ship or an airplane, the windows are always curved. And the reason for that is, right now, if I had a force on that, everything gets concentrated on that one point, which could lead to a failure point. So by curving the edges here, that allows you to distribute the force, instead of having this sharp point where if it gets banged, it gets damaged. It distributes the force more. And we are going to do that. So we've already done a fillet in the sketch, but you can also do fillets outside. So this is the fillet tool here. And with the fillet tool, I can select the radius, 1/4 of an inch radius. That's bigger than I need, but it looks nice, so I'm going to stick with it. And then the edges. And so I'm going to zoom in and click that little tiny edge, and you can see there it fillets it. And there we go. So I'm going to fillet these corners. And the benefit of that, cutting this on the router, is really easy because it just goes around. It's the inner corners that are tricky, because you got to make sure that everything will fit. But that now doesn't have any sharp edges. That's the other benefit, is with metal, by rounding it over, you're reducing the sharp edges, and it doesn't have any points of failure. If we were to bang on this, the force would be distributed around the curve instead of around a single point. So there's an L gusset. That's all designed. Again, we can name things. We're going to hold off on that. We're going to insert part 1, go to assembly, and that takes us back to the assembly. There's our part. We're just going to move it up over to the side here. Now, with the fasten mate for this, again, so there's my fasten mate, and there you can see the blue is pointing up. And what I'm going to do is I'm going to show you, if I'm doing the blue pointing up, look at how this ends up mating. What happens is the L gusset actually goes inside. So I don't want that. I'm just going to cancel that. What I want to do So I want the blue pointing up, but this hole, what I want to do is zoom in and go. So now the blue is pointing down. And the benefit of that is that it fastens the two parts so that the up and down, so that they're on top of each other, which is exactly how I want that positioned. So there's my part. Um, I'm going to insert another one. And what I'm going to do is just let's rotate our view. So this one will go blue pointing up there. Now I'm actually looking upside down, so it's opposite of what I'm saying. But there we go. Really want you to take the time to practice inserting fasten mates. If you make a mistake, just undo it, try it again, um, so that it works. And in here, here's my bill of materials. So I want to make sure L Gusset, that's a name that makes sense. My initials, the project, which is Feb, P for part 01, which is my subsystem, and then this is 03 because it's the third part. And you'll notice that it tells me that there's two of them already. Now, within this, I've mentioned we're using number 10, so let's go to Fastenal. So here's the Fastenal website. When you go to all products, go to fasteners, there are sockets. When you go to sockets, socket cap screws, and then here you have the diameter thread size. So I keep mentioning number 1032. So the number 10 indicates the size. So these are bigger than number 8s, they're smaller than number 12s. And after number 12s, we go into regular quarter inch and stuff like that. So number 1032. Now, the length, so this part is 1/8 of an inch. We have 1 inch and another 1/8 of an inch. So that's 1 plus 1/8 plus 1/8, which is 1 1/4. And we'll need something a little bit longer so the nut can go through it. So it will go for 1.5 inch socket cap screws. So if we go into the socket cap screws, let's filter by length, 1, 1.5. There's 6 screws to pick from. And you can see we want to watch our prices. This is expensive because it's a package. So I'm going to just pick this one that's fairly cheap one. So I mentioned it's a number 1032. The 32 stands for threads per inch. So if I was to measure 1 inch and count 1, 2, 3, 4, 5, I would get 32 of them in total. So that's a fine thread. 1024 is a coarse thread. There's only 24 inches. And when we're dealing with robots, we try to use fine threads because then there's a lot of vibration, and so nuts can gradually work their way out. And by having more of them, it takes longer for it to work its way out, gives you a chance to catch it and tighten it and make sure everything's okay. You can see I know what tool to pick up to get this the right size and everything. So it's 1.5. That's the part number. So in my documents here, what I'm going to do is I'm just going to change my view back to the top. Okay, and I'm going to select this face of the gusset and go Insert, Standard Content. And here I want to pick the ANSI standard. I want to pick bolts and screws, the class, socket head screws, component socket head cap screws, my size, 1032, hex, my length, 1.5 inches. And you can see I've already gone in 2317. Oh, I've picked 174. I wonder why I picked that one. Two, 3, 1, 7. Oh, I better. It's 2.5. Yeah, I better fix that. 23170. So 1.5 inches. That's the size. And if I click insert, that's the beauty, is that it automatically inserts all of them and we're good to go. I didn't need to close the insert because what I'm going to do is I'm going to click the bottom Standard content. This time I'm going to select the category of nuts, machine screw nuts, hex machine screw nut, and 1032. And if I go into Fastenal, fasteners, nuts. Now, I'm using lock nuts and I'm using nylon lock nuts. And this is the beauty, is when you're looking at these things, you can look them up, you can see an explanation about why people would use a certain one. So there's 1032, and you can see I've already specified I like using 37015. So this is a nylock nut. There's a little piece of nylon, and the idea is that when the screw goes through that, the nylon grips on and makes it harder for it to come loose. Makes it harder to put on, but more importantly, makes it harder for it to come off. And as I mentioned, robots tend to vibrate a lot, so that solves that problem. So there's my nuts. Just going to right click on a mate connector and hide all mate connectors. And you can see I've quickly added my parts, my bill of materials. I now have what it is, what the part number is, and how many I need to order. So this makes it really easy, because now I can go, okay, I got to make that myself. I got to make that. I got to make that. That I'm going to buy from Fastenal. That I'm going to buy from Fastenal. So it makes it easy to do some of these different tasks. And we now have a subsystem. We can put this together. It all works.